Okay. 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 So if I will reduce the values. Okay. Otherwise, the MATLAB couldn't. Okay. So you can see that we can get the signal. Okay, but the frequency is very high. That means the cycle number, the cycle one cycle time is very low. When the frequency is very high, period is very low. Period means one cycle time. Okay. Period means one cycle time, it is very low. So you can see that there are many cycles within this time range from 0 to 0.2. There are many cycles. Okay. So you can definitely you can increase the increase the frequency. So it will increase the number of cycles. Okay. It will increase the number of cycles. Okay. So you can see that now we can't see. Okay. So there are many cycles. Okay. Here. Okay. So in the same way, you can increase the signal in minus direction or plus direction. Okay. In minus direction or plus direction. And so when you are increasing the frequency, the number of the cycle time, one cycle time, that means period will be low. Okay. So anyway, so you can get different signal. No, for example, if I get plus 50, okay, so my signal will look like this. Okay. And if I get 500, okay, my signal look like this. Okay. So when we are changing the frequency, we can get different signal. හරි තේරුණාද ඒක තේරුම් ගන්න හරි ඒ කියන්නේ frequency එක continuous time frequency එක යම්කිසි frequency එකකින් තව frequency එකකට වැඩි කරනකොට හරි එයාගේ period එක අඩු වෙනවා. period එක අඩු වෙනවා. ඒ කියන්නේ cycle එක තියෙන ප්‍රමාණය cycle එක මට්ටම අඩු වෙනවා. ඒ කියන්නේ frequency එක වැඩි වෙනකොට cycle එකේ දුර අඩු වෙනවා. period එක අඩු වෙනවා. වැඩි කරන්න අඩු වෙනවා. ඒ කියන්නේ ඔකට ඔයාට frequency එක වෙනස් කරොත් වෙන signal තමයි එන්නේ. හරි? වෙන. ඒ කියන්නේ 500ට ගත්තොත් එහෙම එක signal එකක් 5000ට ගත්තොත් එහෙම තව signal එකක්. 50000 frequency එක select කරගත්තොත් ඊට වඩා වෙනස් විදිය signal එකක් එන්නේ. හරි? එතකොට frequency එක ඕන විදියට වෙනස් කරන්න පුළුවන් ප්‍රශ්නයක් නැහැ. හැබැයි discrete time signal වල ඕක වෙන්නේ නැහැ. හරි? discrete time signal doesn't have this property. Okay. If you are changing this frequency, okay, you can't get any frequency value. Okay. So that this frequency will be only within this range, minus half and plus half. Okay. Okay. So anyone can figure out a point that this is a correct value. Okay. So using one point, we can figure out this, we can verify this. Maybe we can't exactly tell, okay, but we can say with one reason this is correct. Okay. Okay. If you check the period, in the sense of period, actually you can verify this statement is correct. හරි මම කියන එක තේරෙනවද අපේ? ඒ කියන්නේ අපි දැන් සිග්නල් එකේ පීරියඩ් එක ගැන හිතලා කල්පනා කරොත් එහෙම මේ සිග්නල් එක මෙන්න මේ ස්ටේට්මන්ට් එක මෙන්න මේ කන්ඩිෂන් එක අපිට correct කියලා නිකන් verify කරගන්න පුළුවන් සාමාන්‍ය මට්ටමින්. හරි? හරි? කොහොමද ඒක මේව කරන්නේ? How can we verify? If you consider the period, how can we verify it? Okay. So if a continuous time, so what can you say about the period of the continuous time signal? But this is not 100% correct. Okay. It is not 100% correct. Okay. But there is a simple point actually. Okay. So you can see that when you are counting the period, okay, so how you count the period of the continuous time signal? Tell me. If you want to, okay, so let's say that the period means Okay, period means uh, period. If the signal has a period, fundamental period, that means that signal should be repeating. Okay, repeating. Okay. So this, if this is signal is repeating, okay, so that means that signal is repeating. Okay, so one part is repeating again and again. One part is repeating again and again. So that part is called the one cycle actually. That part, repeating part is called the one cycle. Okay, so if you consider this sinusoidal signal, you can see that. Okay, this part, this is one part. Okay, it is repeating here. Again, it is repeating. This one again repeating. Okay, so this is repeating one part. Okay, and if so, that 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 one section is called as one cycle. Okay, and the time of this one cycle normally referred as period. Okay, period. Okay, normally T naught. Okay, so how you find this period of a continuous time signal? If it is txt, okay, how you find the period? What is the theory you should use? Okay, so you need to check one repeating part. No, you need to identify the repeated part. Okay, the okay, so you can so if you consider this one, okay, so this way you can identify it. Okay, so if you consider any point, okay, let's say that you are considering this point. Okay, so the near the so this point, if this is a repeating signal, this point will again come because it is repeating. Okay, so this point is repeating here at the first time. Okay, so this is two near repeating points. Okay, this one and this one is two near repeating points. Okay, we normally called it uh, consecutive repeated points. Consecutive repeated points. These two are the consecutive repeated points. If you consider this point here, and this point is repeating again here. Okay, and this one also consecutive repeating points. And if you consider this point, it is repeating here, and this point also consecutive repeated point. Okay, so if you select two consecutive uh, repeated points, and if you measure the time between that two points, that is the period. Okay, that is the period. So that is how you can calculate the time of a period of a repeating signal. For example, if you have a square signal like this, pulse train like this, okay, so you can see that. Okay, so what is a one cycle? This is a one cycle. No, this is one cycle. Okay, because this is repeating again, and it is again repeating like this. Okay, so actually this also has a frequency. Okay, that means this is a one cycle. Frequency means number of cycles per second. This kind of number of cycles per second, that is a frequency. Okay, and if you select this point, it is again repeating at here. Okay, so this one is one point, and this is the near point, repeating near point. So these are two consecutive repeated points. Okay, if you measure the time between these two consecutive repeating point, you can find the period of this pulse train. Okay, likewise, any repeating signal will have a cycle, and also the time period for that cycle. That period is called the fundamental period. Okay, so this is how we find the fundamental period. Okay, now consider about a discrete time signal. Okay, let's say that like this. Okay, so this is 1, this is 2. Okay, and this is 0. Again here 1, 2, 0. Again here 1, 2, 0. Likewise. Again 1, 2, 0. This is a discrete time signal, no? This is a discrete time signal. So this is 1, 2, 0. This will be 1, 2, 0. Likewise, 1, 2, 0, 1, 2, 0. Okay. And this is normally uh, not referred with time. Okay. Normally this signal is represented with n, number of sample number, not number of sample number. N is the sample number. Okay. And the signal will be xn. Okay. So this is a discrete time signal. Okay. Tell me what is the period of this discrete time signal? What is the period? What is the period? Tell me. What is the period of this signal? So continuous time signal, you use time. Okay, you use time. So your period will be a time value. Okay, so you are measuring the time from here to here. So it is in second or millisecond or microsecond, something with second. It is a time. Okay, now you are representing this discrete time signal. This is a discrete time signal. This is the discrete time signal. And it is the independent variable here is n, number of sample, not time. This is not second. Okay. Don't forget there is a corresponding time value for this n. Okay. So that time value is nt. Don't forget this. Okay. But normally we represent the signal using n. Okay. Sample number. Okay. So what is the period of this signal? Tell me. What is the period of this cycle? So how you find the period here? You need to select two consecutive repeating points. Then you need to measure the time duration between that two consecutive repeating points. Right? Continuous time signal එක සාමාන්‍ය signal එක අපි period එක හොයන්න එහෙමනේ. Fundamental period එක හොයන්න. Repeat වෙන cycle එකක් බැලුවා. ඒ කියන්නේ ළඟම තියෙන repeating point දෙකක් අතර දුර measure කරනවා. ඒකෙන් තමයි අපි signal එකේ period එක හොයාගන්නේ. දැන් මෙයා discrete time signal එකක්. හරි? දැන් මෙයාගේ period එක හොයාගන්න ඕනේ. හරි? දැන් මෙයාගේ period එක හොයන්න නම් ඉතින් ඒ විදිහටම තමයි කරන්න ඕනේ. ඔයා select කරගන්න ඕන consecutive repeating point දෙකක්. කැමති දෙකක්. හරි? කරලා මේකෙදි බැලුවේ මෙතන ඉඳන් මෙතෙන්ට time එක. මෙතනදි බලන්න ඕන මොකක්ද? ඒ දෙක අතර number of sample ගන්න because it is a sample number. n. Okay? Understood? So here in this signal you select two consecutive points, then you measure the time between that two consecutive points. Okay, so your period in second will come in second. Okay, it is a second value, 2 seconds, 3 seconds or something. Right? Now this is a discrete signal. Okay, so our independent variable now is n, that is the sample number. Okay, so how to find the period here? So you can see that this is also repeating signal. Okay, so there is a one cycle. First you have to understand, you have to find what is a cycle. Very easy, you can find it. What is the procedure? You select one point. Okay, so you select this point, that is one. You need to check this point is repeating where? This point is repeating here. Okay, also you can find this one, and this is repeating here, and you can find you can choose this point, and it is repeating here. Any point you can choose, any 2 points. Okay, so I choose this point and this point. So these are two consecutive points. Then I am measuring the period. That means I am measuring in normally for a continuous time signal, I am measuring the time from here to here. Okay. But now I am measuring the sample, because now I am going to tell my period with respect to sample number. So the sample will be here to here one sample, here to here two sample, here to here three sample. So there are, after three sample, again we get the same sample. Okay. For example, here 1, 2, 3. After three sample, again you get 2. Okay. If you consider this point, 1, 2, 3. After three sample, again you get this point. Okay. This point will come here after three sample. So n is equal to 3 is the period for this discrete time signal. If you want to find the time value, you can use t is equal nt. Okay. So there is a corresponding time value. Okay, but normally we represent the period using number of samples. So number of samples should be 3 for this signal. Okay. So any signal, for any signal, the sample number, it is an integer. No? This is an integer. Sample number is an integer. Integer that can have from minus infinity to plus infinity, but it should be an integer. Minus or plus integer, including 0. Okay. So your period should be an integer value. Okay. Your period should be an integer value. Okay. Okay. So okay. So your period should be an integer value. Okay. So you can see that. Okay. For example, if you consider so no, I think that is not the correct point. Okay. That is not a correct point. So I hope that number of so one, if this range, if this limit exceed that n, the number of sample per period will not be a integer value. Okay, I thought like that, but I think it is not correct. Okay. So anyway, okay, we will understand this. Okay, you can understand this. Okay, okay. I will show you this. Okay, don't worry. Okay, so just forget this. Okay, forget about that one. Okay, don't forget how to find the period uh, and how to find the continuous time signal period and how to find the discrete time period. Don't forget. Okay, we need that knowledge again. Okay, so don't forget that one. Okay, but this point you can just forget. Okay, I think I have a mistake there. Okay, so actually I hope that number of sample, using the number of samples per period will be affected to this condition, but it is not like that. Okay, තේරෙනවද මම කියපේ? ඒ කියන්නේ මම හිතුවේ අර number of sample ගාන එක integer ගානක් වෙන්න ඕන පැහැදිලිව. මේ range එක පැන්නොත් එහෙම මේක integer එකක් නැති වෙනවා. ඒ කියන්නේ ඒක integer එකක් වෙන්නේ නැහැ කියලා මේ හිතුණා. හරි. ඒකේ වුණාට එහෙම වෙන්නේ නැහැ. මොකද මේ range එක පැන්නත් integer එන්න පුළුවන්. දැන් උදාහරණයක් විදිහට 1යට 4 ආවොත් එහෙම. හරි. ඒක භාගයට වඩා අඩුයිනේ. එතකොට frequency එක සාමාන්‍යයෙන් අපි frequency එක, if the frequency is f, okay, if the frequency is f, how to find the period? The period will be 1 over f. Okay. So here the frequency is 1, or this is normalized frequency. Okay, it is 1/4. Okay, if it is 1/4, period will be 4. Okay, because 1/1/4. So that is 4. Okay, so period can be an integer value. Okay. Okay, so I think it is misunderstood by me. Okay, so anyway, this condition is there. I will explain. Okay, this condition is there actually. Okay, and so this is the same condition. What here? What you have to do? What it has done? Okay, so this now you have half f plus half. The normalized frequency should be in minus half to plus half. Okay, and if you multiply these by 2/5, these by 2/5, and these by 2/5, what happened? 2/5f, that will be omega, and 2/5, 5, 5, 2 cancel out, so it will be 5, and it will be plus 5 here. Okay, so this is in uh, this is with respect to angular frequency. This is the normal frequency. Okay, so these are same conditions. Okay, these two are same condition. Okay, so okay, so I will explain that phenomenon using this example. Okay, so here we have example. Now you can see that it asks to um, so I will select this signal. Okay, x2t to 50t. I think that is the signal we have selected. Okay, to our program also. Okay, so it is 2550t. I use this signal. Okay, so now I can draw that signal. Okay, so this will be my signal. Okay, now I am going to sample that signal. I am going to sample that signal. Okay, I am going to sample this signal using 40 hertz. Okay, before 40 hertz, I will use around 25 hertz. Okay, so this is the sampling process. Okay, I have typed here the sampling process, here the sampling frequency, and TS is equal to 1/Fs. Okay, and this is how we can map sample number with time. Okay, so I have generated some sample number. These should be integers. I select from 0 to 1000. 10,000, that will not affect to the program. Okay, because I start 0 here, because time also start from 0. That means we don't have minus samples. Okay, so the 0th sample will be the first sample we get. Okay, and the corresponding sampling time TS will be can get using this NTS. Okay, so this is the sampled signal. This is the sampled signal. Okay, and this is the sampled signal. Okay, so sample signal should be with respect to n. What I have done is I replace this t by NTS. This t by NTS. Okay, and you can put n over fs. Anything you can put here NTS also. Okay, when I'm going to draw the signal, I can't draw this signal with respect to n, because this n is an integer and this signal has a time. Okay, so now I am using the same graph to draw the both signal, Okay, so if I use n here, there is no any relation between this n and this time. Okay, so I have to select the corresponding time value actually. Okay, so that I need to draw my continuous discrete time signal with respect to the sampling time, the corresponding sample time, corresponding TS. Okay, so it is like this. Then I limit the x-axis to this time value. Okay, to time value, so that I can increase the number of samples to any point. Okay, So it will not affect. Okay. So if I run this, now I active the sampling. Okay. So you can see that. So it first sampling frequency 1 over fs. Okay. 1 over fs. Sorry. Sampling frequency is 25. That means sample time is 1 over fs. That is 25. Sampling time is 0.04. Okay. So here one sample is 0.02. This one sample, one cycle, okay? One cycle is here to here. That is 0.02 because it is 1 over 50. That is the continuous time frequency. This is the continuous time frequency, 1 over 50, okay? Okay, it is a continuous time frequency, okay? So if you go to this tool and if you get the data cursor, so so this is one repeating point and this is the consecutive repeating point. So here to here it is one cycle for a, I am talking about continuous time signal. Okay, so continuous time signal frequency is 50. That means the period should be 1 over 50. 1 over 50 is 0.02. Okay, you can check it here if you click it. Okay. It is 0.02. Okay, it is 0.02. It, if you get it correctly, yeah, it is 0.02. Okay, so that is a one cycle time. Now your sampling frequency is 25. That means you are getting one sample after 0.04. That means after two cycle. Okay, here. Okay, 0.04. Again after 0.04, you are getting another sample. Again after 0.04, you are getting another sample like this. Okay, so it is like this. So you will get sample like this. Okay, so this is not good because you can see that these informations are lost. Okay, if you get this sample, this information also lost. This information are lost. Okay, so you have this sample, this voltage sample here, here like this. Okay, so now tell me what is the period of this. So the period of the continuous time signal is 0.02. Okay, 0.02. Okay, so that is the period of the continuous time signal. Okay, 0.02, sorry, 0.02 is the period of, that is the time 0 to here. Okay, here it is 0.02. Okay, so 0.02 is the period for the continuous time signal. Okay, tell me what is the period of discrete time signal? It is very easy. You can directly answer. You should be able to answer that question. What is the period? What is the period of the continuous time signal? Sorry, discrete time signal. This orange color one is the discrete time signal. So if I remove this plot, okay, if I remove this um, continuous time signal, okay, if I remove this continuous time signal, okay, so this is the discrete time signal. Okay, this is the discrete time signal. So what is the period of this discrete time signal? This is our sampled signal. Once we sample it from 25 hertz, we get a signal like this. I think it is clear for you, okay? The samples are taken after 0.04 because the sampling frequency is 25, okay? That means you are getting a sample from after 0.04, okay? So yeah, you can see that first sample you get here at 0, second sample you get at 0.04. The corresponding amplitude is 1. Again after 0.04 you get another sample. So the corresponding value is 1. Again after 0.04 you get another one. 0.04 you get another one. Again 0.04 you get another one like this. Okay. So what is the period of this signal? What is the period of this signal? Please tell me someone. What is the period? What you have to do? මොකද කරන්න ඕන? ඉස්සෙල්ලාම identify කරගන්න two consecutive point දෙකක්. එච්චරයි කරන්න ඕන. මේ point එක ආපහු repeat වෙන්නේ කොතනද? Yes, it is that correct. This answer is correct. Okay. The time is 0.04 second. Okay. Now for a discrete time signal, we are normally not using time. Okay. To measure the period, we are not using time. We are using number of sample between two consecutive points. Number of sample. So it should be an integer value. There is a corresponding time value. You correct. Okay. For that number of sample, there will be a corresponding corresponding time. Okay. So time can be calculated using this relation. Okay. Now, how many? So you are correct. Okay. Your answer is correct. We can't say it is wrong. Okay. But I am asking the period with respect to number of samples. Okay. So what is the period with respect to sample? So you can see that this sample is repeating here. This sample is repeating here likewise. Okay. So this sample and this samples are the two consecutive repeated sample. Then what you have to do? You have to measure the number of sample between this point and this point. How many samples there? From here to here? It is one sample. One. You are calculating here. One. Okay. So that is a one sample. So the period is actually here one. The period is one. Okay. The period is one. Okay. So the period is one. Okay. Number of samples. Okay. So the period will be one here. Okay. Now, okay. So now, if you consider the corresponding signal, okay. So we have xt, that is, I can't remember what is the signal given. Cos 25 cos 2550t. This is the continuous time signal. Once you get discrete time signal, it will be cos 2550 divided by 25t. Okay. So 50 divided by 25, it will be 2. It will be 2. Okay. So cos 25. Okay. So now you can see that now the frequency, normalized frequency is 2. Normalized frequency is 2. Okay. But if the normalized frequency is 2, what should be the period? It should be 1/2. Okay, 1/2, because 1/2 period is 1/2 frequency is the period. You already know that. Okay. So the period should be 1/2. N should be 1/2. Okay. So actually this is wrong. This is wrong. It cannot happen. The n cannot be a fractional value. Okay. N should be an integer. Okay. So you can see that if we measure this 50 by 25, the frequency cannot be 2. The frequency cannot be 2. Okay. So definitely it should be less than 2. It should be less than 2. Actually, it should be less than 1/2. Okay. 1/2 less than half. Okay. Less than half. It should be less than half actually. Okay. So if it is less than half, the period will be 2. Okay. The period will be integer value. Okay. So this 2, the period cannot be 2. Definitely it cannot be 2. Okay. Now, how we get the relationship between this? Okay. So the period cannot be 2. It should be below half. It should be below half. The normalized frequency cannot be 2. It should be below half. Okay. So how can you get this relation? How can you get this not relation, the actual relation? Okay. මේ සම්බන්ධ කොහොමද ඔකට ගන්න? Okay. Okay. Okay, so keep it in mind. Okay, so we will select another sampling frequency. I think it is easy. Okay, it is easy to select another sampling. Okay, so as this given. Okay, now let's consider 40. Okay, now let's consider 40. Okay, so if you consider 40, now I am going to change my sampling frequency. Okay, it should be 40. Okay, now my sampling frequency will be 40. Okay, so if I run this, okay, so I will active this one also. Okay. So you can see that now my frequency, sampling frequency is 40. That means I'm going to get sample from 0.025 times after 0.025. Okay. So this is the first sample. Okay. This is the first sample that is at 0. Okay. This is the second sample. Okay. This should be the second sample. So it is in 0.025. Okay. Exactly after the sampling time. This is the sampling time. Okay. So after sampling time, it get one sample, another sample. And again, this is the third sample, second sample actually, it is 0.05. That means again after 0.025, and this will be the next sample. Okay. This will be the next sample. So likewise, you can see that after sampling time, it collecting the sample like this. Okay. So now you see that one sample is here, one sample is here, one sample is here like this. Okay. So you can see that if you you can see that this is one sample and this is, so your signal is like this. Okay, like this, like this, like this, your signal will be like this. Okay, so you can see that these informations are lost and this information are also lost. If we regenerate this signal, this information and this information are lost. Okay, so this is not a proper sampling. Okay, now another problem is there. Okay, okay, now tell me what is the period for this discrete time signal. What is the period for this discrete time signal? Okay. So if I remove this one, okay, then this is the discrete time signal. Okay. So what is the period for this discrete time signal? How you need to find it? You need to select 2 consecutive repeating point and you need to count the sample, number of sample. So how you do it? What is the period of this signal? This is a discrete time signal. So we sample this. This is a discrete time signal. What is the period of this signal? Please answer quickly. We need to do this quickly. What is the period of this signal? So how you evaluate it? So you need to select two consecutive points and count the number of samples. That's enough. Very easy. So this is repeating here. This point is repeating here. So this one and this one are two consecutive repeated point. Okay. Okay. Or you can select this one, this one. So these also two consecutive repeating points. Or you can select this one and this one. This one and this one also two consecutive repeated point. Okay. So if you count this number of sample, that is 1, 2, 3, 4. Okay. So 1, 2, 3, 4. 4. That is the period. Okay, that is the period of this signal. 4. Okay. So it is a number of samples. Okay. That is some number of samples. So this is the period 4. Okay. If it is period 4, what is the frequency? Normalized frequency. It should be 1 over 4. Okay. Normalized frequency should be 1 over 4. Okay. Okay. Now it should be 1 over 4, definitely. Okay. Now you have sample this 50 by 40 sampling rate. Okay. So instead of this T, you can apply N TS or N over Fs. Okay. So here it is applied here. So now you have N and Fs is 40. So this is the frequency. This is the normalized frequency. It is equal to 50 divided by 4. That means 5 by 4. Okay. So this is the frequency we get. This is the frequency we get using the mathematical approach. Okay. Using the mathematical approach, we get this frequency. Okay. The frequency. Okay. I will write it here. Okay. So please try to understand this is okay. This is very important. Okay. So if you consider cos 2550t, this is your continuous time signal. Okay. Now you are going to sample this continuous time signal. Okay. Using 40 hertz. Okay. That means that is your sampling frequency. 40 hertz sampling frequency. Okay. So corresponding sampling time will be NTS. Okay. And TS is the sampling time. It is equal to TS is equal to 1 over Fs. So the corresponding sample time you can write in this way. Okay. So once you sample this signal by 40, it will become a function of N. It will become a function of N, and our signal will be cos 25. So instead of this T, you can apply this NTS, so N divided by 50, N divided by Fs, N over Fs. Okay. So if you apply here N over Fs, so it will be 50 over Fs. Fs is 40, N. Okay. So this is your discrete time signal. Okay. For a discrete time signal, this is the normalized frequency, F. 50 divided by 40 or 5 by 4. This is the frequency for the normalized signal. Okay. Okay. After sample. Okay. But when we sample it using that one, okay, we get the period as 4. That is 1, 2, 3, 4. Okay. So, but in actual sample signal, actual sample signal, okay, sample signal, we get the the period. Let's say that it is n naught, it is equal to 4. Okay. So how to find the frequency, normalized frequency, if period is 4? It is 1 over 4. This is the frequency, normalized frequency. Okay. So this is the sampled signal normalized frequency. And this is the frequency we get using the mathematical one. So is it same? Are these same? Definitely not, no. This is 5 by 4 and this is 1 by 4. So these are not same. Okay, these are not same. That means if you are getting, if you actually you need to, you need, if you sample this by 40, you need this normalized frequency. Okay, this normalized frequency. But actually sampled signal, you can't get 5 by 4 normalized frequency, you get this normalized frequency. So it is change. Okay, it is change. Okay, so if we use this normalized frequency, it is like this. Okay, xn is equal to cos 25 1 over 4 n, 1 over 4 n. Okay, so this is the discrete signal we get actual sound. Okay, so you can see that we haven't this one and we get this one, another signal. Okay, another signal. We get this frequency. We need to get this. We are expecting this frequency, but actually we get this frequency. Okay, so actually this frequency we called aliasing frequency. This is called aliasing frequency. That means this is not the expected frequency. Okay, this is not the expected frequency, but we got this one. Okay, okay. So now you can again come to this point. Okay, now you can again come to this point. Okay, so here there is a condition. Okay, there is a condition. This one. Okay, the frequency should be less than minus half or greater than plus half. Okay, so here you can see that here for this signal that condition is not satisfied. It is 5 by 4, so it is greater than half. Okay, so that kind of frequency cannot be existence. No, this frequency actually cannot be existence. Okay, we have another frequency. So that means it is not like continuous time signal. Continuous time signal, any frequency is okay, realizable. Any frequency can be realizable in practice. Okay, using a signal generator, we can generate it. But if we sample that signal, okay, so we will not get the expected signal, we will get another signal. Okay, so this kind of signal we will not get because it is that frequency is greater than half. Okay, so definitely it will be a lower frequency, so it will be 1 over 4. Okay, so you can get this relation using that one. Okay, I told you that omega k is equal to omega naught plus 25k. We have this identity. Okay, I have showed you. I have shown you here. Okay, actually this say that this omega k is the normalized angular frequency, and this is a fundamental angular. This is called fundamental angular frequency, and this k will be an integer. Okay, this k will be an integer. Okay, so actually you can write this using f. Okay, so f is equal to omega k. If you can write f is like this. Okay, 25 fk is equal to 25 f plus 25k. So this 25, 25, 25 cancel out. You can get fk is equal to f plus k, like this. Okay, so now your frequency is okay. So that means if you have, for example, if you have a frequency of half plus this k can be any integer. It can be 1, it can be 2, anything. Okay. So half plus 1, you will get 3 by 2. Okay. So that means if you have normalized frequency half, that is equal to the normalized frequency 3 by 2. Okay. So this half signal will generate another frequency signal. Okay. So actually this half is aliasing by 3.2. That is the idea. Okay. Uh, I don't know how to explain it. Okay. So please try to understand by yourself. Okay. So once try to understand, then if you have any problem, you can ask, then I can explain it. Okay. So you will get it very clearly. Okay. So what I want to tell you is that this relations actually derived, or okay, this relation and this relations is, those are related to each other. This one, and that fk is equal to f plus k. This one and this one is related. Okay. So if there are any signal greater than half, okay, greater than half, it can be reduced to lower frequency using this identity. Okay. For example, now we have, okay, so we have 5 by 4. This is the frequency we get, 5 by 4. Okay. And we have a fundamental frequency, and this k can be any value. This k can be any value. Okay. Okay. So if you consider this k is 2, if this k is 2, that means 5 by 4 is equal to f plus 2. So f is equal to 5 by 4 minus 2. So you will get, it will be, oh sorry, let's say that this is 1, okay? K is 1, okay? So it will be 5 minus 1, okay? 5 minus 1, when you get 1 here, 5 minus 1. So you will have 5 minus 4 divided by 4. So you will get 1 over 4, okay? So 1 over 4 is equal to 5 by 4, okay? This frequency is equal to this frequency. Actually not equal, okay? Not equal. This frequency, this higher frequency can be reduced to a lower frequency. So now you can see that this frequency is less than half. No, this is less than half. Okay. So that is this, okay? So you can see that. So by sampling, we got this one, 1 over 4, not this one. Not this one. We get this one, 1 over 4. So the any signal should be lie between plus half or minus half normalized frequency. Okay. So that is, I think, please try to understand this concept by yourself. Okay. What I'm explaining here. Okay. So actually, now you can read the story here. That the story said that, okay, once you, so you are going to sample this 2 frequency from 40 hertz. So once you sample this frequency by 40 hertz, what is you get? So it will be cos 25, cos 25, 10 t. T instead of t, you can put n over fs. So fs is 40. So you will have 10 by 40 n. Okay. So this is the signal. So you will have cos 2514 1. Okay. So here you can get cos 251 over 4n. This is the normalized frequency. Okay. So if you get that signal, for example, if you get 10 signal, okay, if you get the 10 signal, this frequency 10, okay, and if you sample it by 40, if you sample it by 40, I will active this plot command also. So this is the 10th signal, okay? Now you sample it by 40. Okay. So one sample you get here, one sample you get here, one sample here, one sample here, one sample here, so on you can get. Okay. So this is the discrete signal. This one, this is the discrete signal. What is the period of this discrete signal? So very easily you can find it. You need to choose two consecutive points. This is one point, this is another point. Okay. Then you have to count the number of samples. So here to here one, here to here two, three, four. So the number of sample is 4. So that is the period. Okay. So if you have cos 2510t, and if you sample this using 40 hertz, you will get cos 25 10 divided by 40 t. You will get this signal. You will get this signal. Okay. Now you can see that the normalized frequency is here to 5, that is 1 over 4 t. Okay. So that is less than half. 1 over 4 is less than half. Okay. So now you can see that at the sample signal also, the frequency is, period is 4. The period will be 4. And not is 4. That means the sample signal frequency, normalized frequency also will be 25, 1 over 4. This is n, okay? And this is n. Okay. So you can see that now the mathematical signal also we can get practically by sampling. Okay. So this one and this one same. Okay. It is happened due to this normalized frequency is less than half. If it is less than half, definitely you will get the same frequency when you sample it. Okay. The normalized frequency also will be same. Okay. So that is the idea. Okay. Now in this case, so you can see now, if you have cos 2510t, when you sample it by 40, you will get the signal that is 25140. Okay. And if you have cos 2510t signal using 40, again you will have cos 25140. Okay. So you can see that in this case and in this case, you get the same frequency, normalized frequency. Okay. But the continuous time frequency is different. Here it is 50. Okay. Different. Okay. But here, okay, you will have same frequency. So this frequency and this frequency will be aliasing if we are using this sampling frequency. Okay. So that is the idea. Okay. So now if you want to get rid of this aliasing, what you have to do? Okay. What you have to do? This nominalized frequency should be less than half. To make this nominalized frequency less than half, what you have to do? Nominalized frequency is the frequency. The nominalized frequency f is the frequency. The signal continuous time frequency is divided by fs. Okay. Now this f you need less than half. Okay. Less than half. Okay. So otherwise what happen? You will get another frequency. Okay, another frequency, that is we are called aliasing frequency. You will get aliasing frequency. Okay, and also it is called as aliasing effect. Okay, so if you need to get rid of this aliasing effect, what you have to do? Okay, this sampling frequency, you can select this sampling frequency, you can select greater than 2 of normal frequency, this frequency. So your normalized frequency will be f divided by 2f, it will be half. Okay. If the sampling frequency, if you choose the sampling frequency, if you choose greater than twice the signal frequency, okay, so the normalized frequency will be less than half. That means it will not create an aliasing frequency. There are no same frequencies you can experience, you can't get. Okay, so this is actually one law. Okay, when you are selecting the sampling frequency, when you are selecting the sampling frequency, you need to select that frequency greater than the greater than twice of the continuous time signal, twice of the signal. Okay, actually this is we called Nyquist theorem. Nyquist theorem. I think you have already learned this one. Okay, Nyquist theorem. Okay, this is the Nyquist theorem. So the sampling frequency should be greater than twice, at least twice of the signal frequency. Okay, otherwise you will get aliasing. Okay, so actually here you have that story. Okay, in here you have that story. So you can see that now this cos 5 n by 2 is equal to this one. Okay, so this is equal using this one. Omega k is equal to omega plus 2 5 k. Using this identity is verified. Okay, so when you read it, try to understand those by yourself. Okay, so uh, so again here that relationship is mentioned. Okay, so please go through it. Okay, so this is the same thing. Okay, this one and this one same. Okay, so if I multiply it by this by 2 5, this by 2 5 2 5 2 5, this will be omega k, this will be omega naught plus 2 5. I here uh, the fs term is there. Okay, so anyway, this one also derived using this one. Okay, derived using this one definitely. Okay, so the sampling frequency also there. Okay, uh, sampling frequency also there. This is a normalized frequency. Not normalized frequency, the normal frequency. And so definitely this relationship should be derived by this one. Okay, so the same thing is there. Okay, same thing is there. So you so try to uh, substitute some value and try to understand by yourself. If you have any problem, you can ask me. Okay, okay, so that is one point. Okay, that is one point. Okay, now again we need to see what is the folding frequency. Okay, what is the folding frequency, and we need to calculate what is the folding frequency. Okay, so I think today we couldn't complete all the things because already that my time now it is already past our 2 hour. Okay, so um, so try to understand these things. Okay, try to understand up to here. Use this mathematical. Still maybe your MATLAB is not working. I will tomorrow definitely I will fix that problem. I will ask IT to fix the problem. Then maybe you can visit it. Okay, so definitely. So please try to understand this by yourself using that. If you can't draw the signal by hand, if you can draw the signal by hand, that is very good. Okay, so you can get the idea very well there. Okay, rather than using the MATLAB, if you can draw this signal in the same time scale, then you can get a good idea. Okay, so try to do that one. Draw the signal by yourself and try to understand the things here. Okay, how the aliasing is happening. Okay, then uh, try to understand this one also, this equation also. Okay, this equation also should be derived using this one. Okay, definitely should be derived using this one. Please check it. If not, I will explain it in next week. Okay, um, and try to read up to here. So very small thing you have to do. Okay, so try to read up to here and try to understand what is fault in frequency. Okay, and then there are some questions. Okay, so try to do these questions also by yourself. Okay, so next week also we will do the same thing. Okay, so if you can refer these up to, actually if you can, now I think maybe so please check the lectures. Okay, so maybe once you go through the lectures, maybe these things you can understand. Okay, so we will see them next week. Okay, so try to understand this by yourself. Okay, this is not easy to understand. Okay, uh, there are some contradiction is there. Okay, but please carefully go through the lectures and read these things and try to understand. Okay, so if you have any problem, please ask me. Okay, actually if you have the question and if I answer the question, then you can understand it very well. Okay, so please try to go through this note and also through the lectures by yourself, by doing the things. Okay, by doing the things yourself. Okay, ඔයාට බලන්න හිටියට ඔක ඔලුවට වැටෙන්නේ නැහැ වැඩි. ඔයාම ඇඳ ඇඳ කරන්න ඕන. හරි. ඔය කට්ටියම ඇඳ ඇඳ කරනකොට තමයි මේක ඔලුවට වැටෙන්නේ. හරි. එක්ක ලෙක්චර් එක දිහා බලලා හරි මේ නෝට් එක දිහා හරි බලලා ඒ සිග්නල් ඇඳ ඇඳ මේක කරන්න. එතකොට ඔය කට්ටියන මොනවා හරි තේරෙන්නේ නැති තැනක් තිබ්බොත් මගෙන් අහන්න. හරි. නැත්තම් නිකන් ලෙක්චර් එක නිකන් අහගෙන හිටියට මේක හරියට තේරෙන්නේ නැහැ ඇත්තට. හරි. ඔයාම කරන්න ඕනේ. එතකොට තමයි තේරෙන්නේ. හරි. Okay. So we will stop here. Okay. Do you have any problem? If you have any problem, you can ask. Otherwise, you can leave. Okay. So if you don't have any problem, you can leave.